folks, so today we're going to be starting with this green sheet, and what I want you to notice about the problems on here is that these are like the quadratic formula where we've already done the first two steps of plugging in the values for A, B, and C, and then simplifying our discriminant. So I like these problems because it gives you practice with like the rest of the simplifying steps, such as simplifying the square root, plus minus case, and how we use division distribution. So folks, we're going to go ahead and just take a look at the first one. We're not going to do all of these. This isn't formal homework or anything. It's just I do think we need this extra practice to get a little bit better with some of just the quadratic simplifying stuff before we practice using the formula itself again. So we're going to go ahead and start with problem number 1. So as I'm looking at that number underneath the square root, is that a perfect square? It is not a perfect square. So what we want to do is use our purple sheet to figure out the biggest perfect square that we can take out of 45. So you can use this sheet in a few different ways. You can either start from the bottom and try to find any perfect square factor that works, or you can start with the number that's less than or equal to the number underneath the square root and start trying to find the biggest perfect square value. So if I start with 36, can't divide 45 by 36, can't divide it by 25, or 16. The first perfect square that I can divide out is 9. So that shows me that I'm going to break this down into the square root of 9. There's the perfect square factor. And then the non-perfect square factor would be 5. And 9 times 5 is square root of 45. So it works out mathematically, and it's going to help us with simplifying because square root of 9 I can simplify to be 3. So first step, break up the square root. Next step is start simplifying it. So remember, we can't divide out that 9 with that 3 because this is inside the radical, inside the square root. That one's outside. So I have to simplify the radical stuff first. So 2 plus or minus 3 square root of 5 all over 3. And now I use division distribution. So divide the 2 by 3, and we get 2/3. Now when I divide 3 radical 5 by 3, the 3's cancel, so we get plus or minus the square root of 5. Oop, and I don't know why I wrote 3 there. That should be a 6. I'm so sorry. That is a 6. This is how my brain is working today. So that should be 1/3. And this would be radical 5 over 2. Now, if I asked you how many roots did we find, what would you say? We found 2 roots, 1/3 plus rad 5 over 2, and 1/3 minus rad 5 over 2. So we would describe these as 2 irrational roots, which means I would be able to see them on my graph, but I wouldn't be able to factor the expression that gave those to me. Moving on to our next problem. We look at what we have under the square root, that's our discriminant, and as soon as we see that negative, what should we do with it? We should bring it out as an I. So go ahead and take that I out. And that will give us -2. You need one of these, the green one or the purple one. So 2 plus or minus I. Now as far as 96 goes, it is an even number, so I might try to divide it first by 4. And when I do that, I see that I get 24. Are there more perfect squares that we can take out of 24? Yep, I can take out a 4 again. So if I can take 4 out and 4 out again, I should be able to take out 16. So 96 divided by 16 gives me 6. So 16, there's the perfect square factor. And 6 is the non-perfect square factor. And that is all over 4. So before I start doing any division distribution, we're going to simplify our radical stuff. Square root of 16 is 4. We throw the I behind it. Square root of 6. And this is all over 4. So now from here, division distribution to simplify. Negative 2 divided by 4 is a negative 1/2. Plus or minus, when we divide the right side by 4, I can take out that coefficient of 4 with the 4 in the denominator, and that gives me I radical 6. And those would be my solutions. Negative 1/2 plus I rad 6, negative 1/2 minus I rad 6. So from here, how would I describe these? The 6 is irrational, but as a whole, and because of the I, we would describe these as 2 complex roots. So it doesn't matter what else is involved numerical-wise, as soon as I have that I, the roots are automatically complex. Which means I wouldn't have been able to factor it, and our only option would have been the quadratic formula. Now, moving on to number 3, when I go to simplify that square root, what's the biggest perfect square we can take out of 4? Psych, 4 actually is a perfect square. So I don't need to break it up into factors at all. We would just have 4 plus or minus square root of 4 is 2 over 8. From here, division distribution. So that gives us 1/2 plus or minus 2 over 8 is 1/4. Now, when I asked third block if that was simplified, they're like, yeah, it's simplified. We did carry out division distribution, but it's not quite there yet. Because these are rational, we can simplify this a little bit further. So I want you to put a box around this and write not simplified. So how are we going to simplify it? This is where we break it down into the plus case and the minus case. We say, well, what is 1/2 plus 1/4? And what is 1/2 minus 1/4? Well, 1/2 plus 1/4 will be 3/4. And then 1/2 minus 1/4 will be 1/4. So instead of having this plus minus expression, we now have found the exact roots. And how we describe these is 2 rational roots. So the rational root ones are the ones that are a little bit tricky when you're doing the quadratic formula, because you actually can simplify it into that plus case and the minus case. So if you're worried, like, ooh, I don't know if I'm going to remember to do that, anytime you get a rational number under the square root or a perfect square, that's indicative that you should be getting rational roots, which means you should be able to do what with that original quadratic? You should be able to factor it. Factoring is what leads us to those rational roots. So if you get a perfect square under there, you should be able to factor from the get-go and not even mess around with the quadratic formula. Let's go ahead and look at the next one. Now, negative 98, as soon as I see that negative, we're going to take it out of the square root as an I. So negative 2 plus or minus I. Oh, okay. Here's the green sheet. Now, 98 is even, so you might try to divide it by 4 first. 98 divided by 4, that's a no-go. It is even if I divide it by 2, which 2 is not a perfect square. We see that its perfect square factor is 49. So again, you could just start working your way down that purple sheet list and trying to find the perfect factors, or you can start dividing by items, trying to make a factor tree to find the perfect squares. So we see that 49 is our perfect square factor, and 2 would be our non-perfect square factor. This is all over 14. So from here, we gotta simplify all that radical stuff fully. So the square root of 49 would be 7. Then I, radical 2 over 14. Using division distribution, negative 2 divided by 14 would be negative 1/7 gross. We can take a 7 out of both the 7 and the 14, and that leaves us with I square root of 2 over 2. Yuck! So unfortunately with the imaginary ones, there's no way of checking ourselves other than looking at the graph and seeing that there are no real solutions. So there are no x-intercepts that I can actually see on the graph. So this would be 2 complex roots. What questions do we have so far? All right, moving on to the next one. We do have a 0 in front, which is a little unusual. So 0 plus or minus, what's the biggest perfect square factor I can take out of 32? Give you a hint, it's not 4. 16. 16 is the biggest. And the other factor then is 2. So 16 times 2 is 32. 16 is our biggest perfect square. So when we go to simplify this, we still have that weird 0 plus or minus. The square root of 16 is 4. And all over 4. Now when I do division distribution, what's 0 divided by 4? 0. What's 4 divided by 4? 1. So I get 0 plus or minus 1 square root of 2 or just square root of 2. Folks, do I need that 0 in front? Nope. Do I need the plus or minus 2, radical 2? Yes. So that plus or minus is still important because that's what shows me that I have 2 solutions. So you don't need the 0. But the plus or minus in front of the radical 2 shows us that we have 2, and how would we describe these? Irrational solutions. Irrational. So I know it's kind of confusing because irrational starts with the letter I, but it's the complex roots that are imaginary, and it's the nasty square roots that are irrational. I want you to go ahead and try number 6. And number 7. I'm going to give everybody a couple minutes to try those two. So we're just intermediately starting the quadratic formula. So you're simplifying the square root and then doing division distribution. Yeah. So 0 divided by 4 is 0. 4 divided by 4, those cancel, and we're left with the plus or minus radical 2. So folks, on this one, 36 is a perfect square. So the square root of 36 would just be 6. And this is all over 9. So once my radical is simplified, I'm ready for division distribution. So negative 6 over 9 is negative 2/3. And then positive 6 over 9 is also 2/3. Now, is this fully simplified since these are both rational? Nope. This is one, again, where we need to do the plus and minus cases because I can actually add and subtract those 2/3 fractions together. Can I actually add negative 1/7 to that imaginary stuff? No, real stuff stays separate from the imaginary stuff. Same with up here. I can't actually add that fraction to that nasty square root stuff. So anytime you have a square root left or an I involved, you're not going to be able to add or subtract those items together. But here, since they are both rational, we're going to have the plus case and the minus case. Negative 2/3 plus 2/3. Don't use your calculator. What is it? It's 0. Negative 2/3 plus 2/3. And then the minus case, negative 2/3 minus 2/3. Common denominators, add those tops, or you can always use your calculator. Negative 4/3. And what we have found are 2 rational roots. Raise your hand if you're already done with number 7. Okay, if you haven't tried that one yet, go ahead and do so now. If you're done with 7, you can go ahead and start number 8. So on number 7, as soon as we see that negative under the square root, we know that we're going to have complex solutions. So we start by bringing that out as an I. My perfect square factor of 75, if you think about quarters, would be 25. So 25 is the perfect square that goes evenly into 75. And then the non-perfect square factor is 3. This is all over 3. So 5 plus or minus, the 25 under the square root turns into 5. Then we get I, and then the square root of 3 all over 3. Hey, can I cross off that square root of 3 with that 3? Nope. So you can only do outside or coefficients with that bottom term. We can't steal stuff from underneath the square root. So when I simplify this, we get 5/3. Can't even simplify it. And we get plus or minus 5I rad 3 over 3. And yuck, that's my final answer. We don't like it, but there it is. And how we would describe these is 2. Complex, because of the I, roots. So as soon as you have that I, that overrides anything else you have in the problem. Doesn't matter that there's an irrational 3 there. As soon as you have the I, you automatically have complex roots. Let's go ahead and look at number 8 then. So for 8, as I'm looking at 54, anything jumping out at you as the biggest perfect square? You can start dividing your way down that list on the purple sheet, and what we find is 54 is divisible by 9. So 9's our perfect square factor, 6 is our non-perfect square factor, and this is all over 3. So simplifying first, 6 plus or minus 3 square root of 6, all over 3, division distribution. And 6 divided by 3 is 2. The 3's cancel here, and I'm left with the plus or minus radical 6. So we ended up with a nasty square root, so this would be 2 irrational roots. On your own, get as far as you can in 1 minute on number 12. I think that'll be the last one that we do on this page. So hopefully you saw that the biggest perfect square you can take out of 24 is 4. Because it's negative, we automatically take out the I. But this is why I wanted to go over this problem. Folks, when I do division distribution, a lot of times we show these two crossing off. But do they cross off to be 0? What is 2 divided by 2? It's 1. So yes, they do cross simplify, but they cross simplify to be 1. So I got to have that 1 out in front of that plus or minus, and what I'm left with on the right side is I square root of 6. Those are the final answers, and we would describe these as 2 complex roots because of the I. So it doesn't matter what else is there with it. Anytime we have I, it is automatically complex. All right, folks. So we're not going to do any on the second page together, but these solutions are posted on Canvas. So if you're like, I think I need more practice with just the simplifying part of the quadratic formula, these are great problems that you can use. I don't have an answer key made for this page, so don't do these ones. But any of the other problems you are perfectly fine to do for extra practice. So upon seeing third block's homework quizzes, it's kind of all over the place. So if you need extra practice, do extra practice. If you say, I'm 100% fine with the quadratic formula, I'm not going to force you to do that stuff. So it's totally up to you on the extra practice that you feel like you need. We're going to go ahead and take a quick bathroom break, phone break before we move back into the guided practice.